Okay, so today we're doing section 4.6, using congruent triangles. These are things that you can do if you already know that the triangle is congruent. So if I've got this triangle, and let me draw it out here for you. You've got a triangle like this with a line down the middle, and this is F, G, K, and H. And we've already said that the two angles are congruent. So if that's true, then I know that corresponding sides are going to be congruent. So that means that FK is going to be congruent to HK. And it's going to mean that FG is congruent to HG. And then finally, the one we always remember in the middle, where they share a line, that's congruent by reflexive. So you've got KG is congruent to KG. Okay, the same is going to be true for the angles. So all the angles are going to be congruent. So I know angle F and angle H are congruent because they're corresponding. And then I know that this one and this one are congruent. So that's angle FKG is congruent to angle HKG. And then finally, this one down here has to be congruent because it's a corresponding part. So we have angle HGK is congruent to angle FGK. Okay, and the way we can do that is our new reason for our proofs, and that's that corresponding parts of congruent triangles are congruent. And we can just use the CPCTC. Okay, but you can only use it if you've already proven triangles congruent. So I'm going to write that in here. Only when the triangles already proven congruent. Okay, so let's see how that would look in some of our proofs. Okay, I'm going to start with our given. I've got GK bisects angle FGH, and I'm going to write it separately. GK also bisects angle FKH. And that is our given. Okay, now the definition of a bisector is that it cuts, if it's a segment bisector, it cuts the segment into two equal parts. If it's an angle bisector, it cuts the angle into two equal parts. So for angle FGH, since this line cuts it into two equal halves, those two angles are going to be congruent. So angle FGK is going to be congruent to angle HGK. But also, on this side, because this line bisects both of those angles, so these two are going to be congruent. So angle FKG is going to be congruent to angle HKG. And that's because of angle bisector. That's that definition. So we've got two corresponding angles. We need a side that's congruent somewhere. And we can always rely on the one where they share a line. So I know that KG is congruent to KG. And of course, that's the reflexive property, POC. Okay, now I have two angles and a side, and the side is between the two congruent angles. So I know that these two triangles are congruent by angle, side, angle. And once we've proven that those are congruent, now I can prove what I've been looking to prove, which is FK is congruent to HK. Oops. It's congruent to HK. So FK is congruent to HK because those are corresponding parts. So because we've already proven the triangle is congruent, corresponding parts of congruent triangles are congruent. And that's how we prove that. Okay, let's look at one that's a little bit different. I'm going to start with my statements. I've got AB is congruent to CD, and AD is congruent to CB. And those are my given statements. And I'm going to go ahead and mark them. So AB and CD, AB is congruent to CD, and AD is congruent to BC. So that's those. Okay, and again, we're trying to prove the triangle is congruent first. And I don't have any angles, but I have the reliable shared line here. So I know that DB is congruent to DB, and that's because of the reflexive property. And that's a POC. Now that I have all three sides congruent, I know that the two triangles are congruent by side, side, side. Once I've proven the triangle is congruent, any corresponding part's going to be congruent. So ABD is going to be congruent to CDB because they're corresponding parts. And again, that's corresponding parts of congruent triangles are congruent. Now, what I'm trying to prove is that AB is parallel to DC. And if that's true, then these two angles are alternate interior angles. Whoops. And they're alternate interior angles. And we're using them to prove that the lines are parallel, so this is a converse. Okay, we're reaching back into the previous unit. And that allows me to prove that AB is parallel to CD. That's all I've got for you, and I'll look forward to seeing you tomorrow. Thanks.